We want to look at the steady state in the basic Solow model where we don't have any population growth or any technological progress. Now, first, let's look at what do we mean by steady state. Now, in the Solow model, steady state is the long-run outcome of the model. Now, when we look at our basic Solow model, where we don't have population growth or technological progress, so at the steady state, capital per worker and output per worker are no longer changing. So that's how we're defining a steady state in this model, that capital per worker and output per worker are not changing, are constant in the basic Solow model. Now let's first look at how do we find steady state capital per worker. We know lowercase letters are used to denote per worker variables, like capital K represents your aggregate capital, but your small k represents capital per worker, and the asterisk over here in our Solow model denotes the steady state value. So let's first look at how do we mathematically solve for steady state level of capital per worker. Now, like we said in this model, the steady state is defined where capital per worker is constant. So this means change in capital per worker, which we found through the capital accumulation equation as investment per worker minus depreciation per worker in our basic Solow model, that's equal to zero. So like we said, in this basic Solow model, steady state is where capital per worker is constant, which means change in capital per worker given by a capital accumulation equation, which we're saying is equal to zero. So from here it follows the steady state value of capital per worker is where your investment per worker is equal to depreciation per worker. So in this basic Solow model, if you want to find the steady state level of capital per worker, that's essentially where investment per worker is equal to depreciation per worker. Where investment per worker is your savings rate times your output per worker, which is given to us by a per worker production function, and depreciation per worker is the depreciation rate times capital per worker. So the steady state value of capital per worker is such that the amount of investment per worker is just enough to cover depreciation of the capital stock per worker, keeping capital per worker constant. Any more investment than that will increase capital stock, and any less investment than that will reduce capital stock, right? So mathematically, if you want to find the steady state level of capital per worker, just keep in mind here in the Solow model, steady state is where capital per worker is constant. So change in capital per worker given by the capital accumulation equation is equal to zero. So from here it follows that investment per worker is equal to depreciation per worker. So to find mathematically the steady state value of capital per worker, we're just setting investment per worker equal to depreciation per worker in this basic Solow model. The way we find it in when we introduce population growth and technological progress changes slightly. Depending upon that over here, then we have to count for other stuff like population growth and technological progress. So graphically, now that's mathematically. To mathematically find the steady state value of capital per worker in this basic Solow model, you just set investment per worker equal to depreciation per worker. Graphically, the steady state value of capital per worker occurs at the intersection of your depreciation per worker line and your investment per worker curve in our Solow diagram. We know in our Solow diagram, we have the depreciation per worker line, we have our output per worker, i.e. per worker production function, we have investment per worker curve. Now, it's at the point of intersection of the depreciation per worker line and investment per worker curve that we get a steady state value of capital per worker. Because at the point of intersection, depreciation per worker will be equal to investment per worker. They're intersecting at that point. So at that point, change in capital per worker, which is investment per worker minus depreciation per worker from our capital accumulation equation, that's equal to zero. So this is the steady state. So mathematically, if you want to, in this basic Solow model, find steady state value of capital per worker, you just set investment per worker equal to depreciation per worker. Graphically, the steady state value is at the intersection of the depreciation per worker line and the investment per worker curve in our Solow diagram.